Material Requirement Planning, MRP. Independent versus dependent demand. Independent demand for finished products. Dependent demand for items that are sub-assemblies, parts, or raw materials to be used in the production of finished products. Materials planning is concerned with planning to meet demand for dependent items. This shape represents the independent demand not related to other items. And the other shape is represent the demand for dependent items as subparts and assemblies that require to produce one items from finished product. These items is derived from the need to produce certain amount from the finished product. We can determine or derive material requirement planning from the dependent demand. This table represents the difference between materials required with independent demand and the materials required for dependent demand. Demand source, company customers. The other is parent items. Materials type, finished products, parts and raw materials. Method of estimating demand, forecast and the customer order. The other is calculated of the items that is required. Planned methods, economic order quantity. The other is material requirement planning. This figure represents how we determine or prepare materials planning, MRP, which is computer program. We need first the firm aggregate product plan and forecasts of demand from random customers and firm's orders from known customers. All these can be help in determine master production schedule, MPS, which input to material requirement planning. We also include inventory transaction or inventory record file and engineering design changes in the bill of materials file. After that, the program determines the primary report and the secondary report, which considers the output of this program. Material Requirements Planning, MRP, is manufacturing computer information system, determines quantity and timing of demand for dependent items. What operation manager should know in the material requirement planning model? Effective use of MRP requires that the operation managers know master production schedule, what is to be made and when, specification or bill of materials, how to make the product, inventory availability, what is in stock, purchase order outstanding, what is on order, lead times, how long it takes to make or get various components. This figure represents the material requirement planning system. The input include MPS, Master Production Schedule, Bill of Materials, the component to produce one product, inventory records. These three items is input to material requirement planning program. The output consists of primary reports, planned order schedules, order release changes, and secondary reports, performance control reports, planning reports, and exception reports. And also the output include inventory transaction. First, the material requirement planning inputs, which include master production schedule, states which end items are to be produced, when they are needed, and in what quantities. Bill of materials boom, a listing of all of the raw materials, parts, and sub-assemblies needed to produce one unit of the product. Inventory records includes information on the status of an items during the planning period, example, quantity, supplier, order lead time, and lot size. Material requirement planning processing include the following. For each time period: growth requirements, schedule receipts, projected on hand, net requirements, planned order receipts, planned order release. The output include primary reports, planned orders, schedule indicating the amount and timing of future orders, order release, approval for the implementation of planned orders, changes of due dates or order quantity or cancellation of orders. Material requirement planning outputs for secondary reports include performance control reports, evaluation of system operation, including deviations from plans and cost information, planning reports, data useful for assessing future material requirements, exception reports, data on major differences in encountered come across. This figure represents material requirement planning, which began with develop a tentative master production schedule, which used to determine or simulate material requirements, convert material requirement to resource requirement, and ask if capacity adequate. Yes, firm up a portion of the materials production schedule. No, the capacity is not adequate. Can capacity be changed to meet requirement? Yes, change capacity and firm up a portion of the master production schedule. If the capacity change cannot meet, revise tentative master production schedule. Benefit of MRP: increase customer satisfaction due to meeting delivery schedules. faster response to market changes, improve labor and equipment utilization, better inventory planning and schedule, reduce inventory levels without reduce customer service. Manufacturing resource planning MRP second involves the whole production process, starting with aggregate planning, then master production schedule, and finally master requirement planning. Emphasize integration with financial planning, marketing, engineering, purchasing, manufacturing, personnel. This shape represents manufacturing resource planning MRP second. To prepare production plan, we need market demand, manufacturing, and finance and marketing situation. And from that we can prepare production plan and determine capacity planning. If there are problems, yes, adjust production plan until we not have problem. So we go to master production schedule and determine material requirement planning. Is capacity planning enough? If there any problem, if yes, adjust master schedule. If there is no problems, determine requirement schedules. Bill of materials boom. List of components and quantity needed to make product. Provides product structure tree. Parents item above given level. Children items below given level. Shows low level coding, which means the lowest level in structure items occurs. Top level is 0, next level is 1, and so on. This example of a bill of materials for bicycle. The component that needed to produce 1 bicycle. Problem 1. Use the product structure tree to determine the low-level coding and the quantity of each component to produce 100 units from product W. We need now to determine the component need to produce 1 from W. First 1 from W, and then calculate the amount that is required from all these parts and subparts to produce 100 units. First, we look to the product structure tree to see the component and the need, what quantity of each of them. Product W, to produce 1 unit from it, we need C 4 parts, from B 2 parts, and from A 1 part. This is represent level 1. Level 0 is the main product. And in level 2, to produce 1 item from C, we need 2 items from G and 3 items from D. And to produce 1 item from G, we need 1 item from D. And so on from the remaining parts. To make the solution, we look for the parts and we need to determine the levels of each parts. D must be in the level 3, and so D from the part A to be in the same with the in the same levels with each others. And we look to determine the remaining of the parts. We begin from W. We need 1 part from W and 4 from C and from B2 and from A1. Each one from C needs 2 from G. We multiply 2 times 4 means we need 8 from G. And from D we multiply 1 times 8 from G, we need from D 8. And the other branch of C, we need to produce 1 part from C, 3 parts from D in this branch. We multiply 3 times 4 equal 12. The other parts or branches to produce B, we need to produce 1 from B, 1 from F. We multiply 1 times 2 equal 2. And E, we need 2 from E to produce 1 from B, but we need 2. So 2 times 2 equal 4. The last branches, we multiply 1 times 1 equal 1. E, to produce 1 from A, we need 1 from A. So we multiply 1 times 1 equal 1. For D, we need 2. 2 times 1 equal 2. We begin to calculate the level of each items and the quantity to produce 1 unit from W and 100 units from W. Level 0, this is the main items. Problem 2. Use the following product structure tree to determine the low-level coding and the quantity of each component to produce 2,200 units from the product S. To produce 1 from product S, we need from W2, X8 and Q4. To produce 1 from W, we need 6 from A. Other branches needs also 5 from A, 3 from H to produce 1 from A, and so on for the A other parts to produce the product S. Now we look for the level 3. We have H and T. We look of level 3, we see that there is H and T in level 3. We must make these parts with the others in level 3. And then calculate the needed for each part. This is what we've done. We make H and T in branch X and branch Q in the level 3 with the other of branch W. And then we calculate the amount of parts that is needed to produce 1 from top to down. First S, we need 1. W, 2 times 1 equal 2. And for the level 2, A, we need 6, and 6 times 2 equal 12. The other branch of W, to produce 1 from W, we need 5 from A, but we need 2. Multiply 5 times 2 equal 10, and H, 3 times 10 equal 30. The other branches we need from X, 8. To calculate what we need from L, 4 times 8 equal 32. T, for each of L, we need 3 from T. 3 times 32 equal 96. The other branch, H, we need to produce 1 from X, 8. H, each one of them needed 7 from H. 7 times 8 equal 56, and so on. Now we will calculate the amount, and if we look, we see A, it is the repetition in the parts. We sum this is the needed of quantity from each part to determine the total needs. Level 0, this is S, item S, one quantity from S1 times 220, we needed 220 from S. This is the main product. Level 1, we have Q, X, and W. From Q, we need 4. From X, we need 8. From W, we need 2. We multiply this quantity by 220 to determine the total quantity we need to produce 220 from product S. This is the numbers after the calculation. Capacity requirement planning, it is another type of problems in these sections. Use the following production schedule to determine the labor and machine capacity requirement for each week and compute the percent utilization of labor and machine in each week if labor capacity is 120 hours per week and the machine capacity is 200 hours per week. Production schedule divided into 4 weeks. This is quantity needed for each week. Standard time labor, we need 0.25 hours per unit from labor force, and from machines we need 0.50 hours per unit. Solution needed to be calculate capacity requirement, which equal quantity times standard time. Now we begin to calculate the capacity requirement for labor force and machine force. First, we multiply the quantity in each week by 0.25, which represent the requirement for from labor force to produce 1 unit. And also we calculate the capacity requirement from machine by multiply the quantity needed for each week times 0.50, which represents the standard time to produce 1 unit. And after that we calculate percent utilization, capacity requirement divided by available capacity, 120 hours per week for labor and 200 for machine. Percent utilization labor capacity in week 1 and 2, and for percent utilization machine capacity for week 1. These numbers will be we will see after finishing the first table. The first table, the capacity requirement, we multiply 200 in the first week times 0.25 equal 50, and for second 400 times 0.25 equal 100, and for third equal 25, and for fourth equal 60. Capacity requirement for machine, the quantity in each week, we multiply each week quantity by 0.50 to see what is the requirement from machine capacity. We need for first week 100, and for second 200, and the third 50, and fourth 120. Percent utilization capacity requirement divided by available capacity. Available capacity 120 hours per week for labor and 200 for machine. Percent utilization labor capacity for week 1 equal 50 over 120 equal 41.60%, and the percent utilization machine capacity for week 1 equal 100 divided by 200 equal 50%. This table represents the calculation of utilization needed from labor capacity and machine capacity. This is another problem. Use the following production schedule to determine the labor and machine capacity requirement for each week, and compute the percent utilization of labor and machines in each week if labor capacity is 200 hours per week and the machine capacity is 250 hours per week. The production schedule and standard time for labor and machine. The solution required: calculate capacity requirement, which equal quantity times standard time. As we mentioned before, the quantity in each week multiply the labor standard time equal the following. And for machine, we calculate the requirement by multiply quantity in each week times 1. And after that, we calculate the percent utilization for machines and labor. This time, the capacity for labor is 200 and for machine is 250. This is the number. This is the end of the example.